Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard on the MakeCode Forum.
I'm Joey at J Wonder on the MakeCode Forum.
And today we're going to be working on our seagull game. You guessed it. So, if you haven't been with us as we've worked on the seagull game, this is a game where you use the mouse to interact with switches, and you're trying to guide seagulls to a bagel. And so we have all sorts of little things that you can interact with. And where we left off last time we worked on this was we have these wires in the game. And we want to make it so that you can interact with wires or with buttons, and the on-off state will travel through those wires to affect walls or what have you. Right, so up to this point, when you click one of these switches, we've only been having them interact with things that they actually touch. And so this will be a new thing that'll let us test with wires. Mm-hmm. And let me start by just getting rid of this so that in our test level, we don't ever go to the next level. Okay, so we have these two buttons right here, and we want flipping these buttons on to affect the blocks that they're connected with wires. So right now, this should be on, and this should be on. And then if I flip these, this one should turn on, this one should turn off, this one should turn off, this one should turn on. Yeah, you get the idea. So today, we're mainly going to be refactoring code. I mean, what's more exciting than that? But so up to this point, our code has mainly been working by just kind of doing a breadth first search on the adjacent tiles, looking for all of the tiles of a certain type and then flipping them. So the idea being that we check all of our connected tiles and make the jump. Only if we are touching more tiles of the same type. So that's not going to cut it anymore because now we have these wires. And we've written some code to trace wire paths, but we also need to make it so that when we trace these wire paths, we can kind of continue them. Because in addition to this demo level, and actually let's create a different demo level. Let's see, I'm going to duplicate this. Get rid of that, grab a new tile map, put that in here. And we're going to fill this in with some demo kind of contraptions. So I'm just going to trap our seagulls up here because, we don't actually want them to move. And we're going to go ahead and create a button. We're going to create some green walls. We're going to create some blue walls. And we're going to go ahead and make some wires. All right. So when Joey and I were talking about this last week, we decided that a case like this should be supported. Okay. Mm-hmm. So with this one, when you turn on, this should turn on, and this should turn on, right?
Yes. Basically, we think of it as there's a wire behind each of them, like a cross-section wire. That's how I was thinking of it.
What isn't supported, though, is that this will not turn on.
I hadn't thought about that case. I trust your judgment.
No, think about it. I literally don't know if this is the right answer or not, but this is what we talked about last week.
Yeah. I guess with how I was visualizing it, this would probably turn on.
Okay. So we just treat a continuous block as a... All right. I guess that is the most consistent option.
Yeah. Otherwise, you have to determine direction. Or I guess we could make the point there has to be the wires can cross between green and blue, but the green and blue can't cross themselves.
Yeah, no, I think you're right that it's probably the most consistent for us to support this. So let's go ahead and update our case so that we can actually have that.
Test it, yeah.
And then to further complicate things, we're going to go ahead and put this one right here and connect it like this. All right.
Yeah, it's just the same switch. Well, oh, it's not the same. Yes.
Correct. Yes. So switches do not turn on other switches, right? So this one will, turning this on will not turn this one on. But it will potentially prevent. Well, now, okay, so now it gets kind of complicated, I guess, because if we have two switches, now they can never be. You can have them all on, or you can have half of them on. Yeah, I guess that's fine. Yeah.
I think that was the case before too, right?
No, because we didn't have any transferring between.
Yeah, but you could do two switches, green on top and then blue in between them.
True. Yeah, you could do that. Okay. So, all right. We're going to have to refactor our code to make this work. I think what we're going to do here is we are just going to make a function that is going to get all connected tiles for a switch. All right. So given a starting location, we will just traverse all of these tiles, and all of these wires to figure out our entire set. And then we will just do all of our things on that. I think that's going to be the easiest way to do this. So let's make a new function that does that. We're going to go ahead and go into functions. We're going to go ahead and do get all connected blocks. And this is going to take in a start location. So this is going to be just called start. And we're going to go ahead and make a variable called temp location list. And we are going to set this to be an empty array. And now we are going to make another function, which is going to be called trace path 2. It's called trace path 2 because we already have a trace path. And this is going to be like a super trace path, basically. So this one's going to kind of invalidate all of our other ones. So in here, we are going to take a 2 arguments. So we're going to take a previous location. And we are going to take a current location. And we're going to take in our array of locations. All right. So with this, we're going to be just pushing things into our array. All right. So what we're going to do here is we're going to go ahead and inside of our get all connected blocks, we're going to go ahead and do function call trace path 2. And for each of these, we're going to pass in our start location, and then we're going to choose an adjacent location. And we're going to pass in our location list. And we're going to call this 4 times, 1 for each direction. And then we're going to return this variable at the end. All right. So while we're doing this, we do have to make sure we don't reassign this temp location list inside of our recursive calls that we're going to be making inside here. We're not going to have that issue, but it's just something to think about. You know, if you see me do that, call it out.
We might need to make a super temp location list in that case, if that were to happen.
Yeah, I don't know. Or, you know, we could just call, like, the other way to do this is to make this return this array, and then you can just nest it and then do a return, and then you don't have an issue.
Make this return this way. I mean, we could just pass in an array, empty array as well.
Well, but we need them all to have access to the same array, because we're going to be using this to also check if a location is already visited or not.
True. Yes, I meant make get all connected blocks have an array parameter, but that's not as clean.
Make get all connected
blocks. And just treat it the same as temp location, but just then it's scoped to the function.
I see. Yeah, but I mean, like, we can get rid of any of this if we were to just, like I said, make this return array of locations at the end.
True.
And then just do return. Gosh, now I'm gonna do it. And then just do this. And then just keep calling it like that.
True.
And then we pass an empty array over here.
Well, yeah, pretty much the same.
Make this top, right, bottom, and there we
go. It's a fun looking function.
Yeah.
The nice thing about functions, for anybody who doesn't know, is you can do right click and collapse, or that top right arrow.
Yeah. So we can just put that away and never think about it again.
Yeah.
All right. So we need to call this function on all of our locations. So the first thing we're going to do is we're going to check if this current location, let's see, do we also need to have a visited array for all of the, I think the answer is no, because we just immediately terminate whenever we find any, yeah, we don't have to worry about that. So what we're going to do is we are going to loop over our tile at our current location and then move based off that. So let's go ahead and grab I'm going to open up our trace path function, wherever that is. Here we go. And I'm going to steal this if statement. Put that in here. Okay. So inside here, we have a bunch of returns, right? So we were returning the trace path thing based off of the tile map location, right? So we don't actually want to do that. We're going to go ahead and go into functions, and we're going to recursively call trace path 2. We do not need to return it because the return value here is really only being used to avoid that temporary variable. So for each of these, we're going to have the same arguments. It's going to be current location, and then the next location is going to be whatever is currently inside of this return. And then we're going to be passing our array of locations like that. So go ahead and toss this. And then we're going to replace all of these. So let's call it on top. This one's left. This one's bottom. This one's right. This one is bottom. This one is left. This one is top. This one is left. This one is right. All right. This one is, let's see, top. This one is bottom. And then toss that. Okay. All right. All right, so there's one fix we have to do here, which is we have this other function. Which is wire attached to switch? Okay, so this one actually checks to make sure that we can be connected in this direction. So as long as this is a wire, it will return true given the current location and the current location and the previous location, if this is a valid wire connection. So we're going to go ahead and grab all of our wire traversing stuff here. And we're going to wrap this in one big if statement. And we're going to go ahead and call our is wire connected function. There you go, is wire attached to switch. The first argument is the switch, which is which is previous location. And then the next one is current location. Okay. So this is just going to make sure that we never do something like, let's go right here and grab a horizontal one, put that right there. Or actually, that's not a very good example. Let's put this right here and then put this right here. Okay, so this should not activate, right? So this is basically just handling that case, which is we encountered a wire. We need to make sure that we could have validly come into this wire, right? As opposed to coming from, perpendicular.
Wires are not cross-section.
Yeah, why is this angry? Not all code paths return. Oh, stick that. Cool. Okay, so that handles the wires. And we don't have to actually add these to our array because we don't actually care about wires. They are purely for connecting. So next up, we're going to go ahead and do tile at current location is, and now here's where we want to start looking for all of our different blocks. So we have all of these dotted line blocks, and we have all of these undotted versions of the blocks. So we're going to be looking for all of this. So maybe we should just make an array. Like that. All right. And we can go ahead and do an index of here. There you go. Stick our array in there. And then instead of doing this if check here, let's just go ahead and go into scene and grab the tile at location. Yeah, tile image at. And then pass in our current location. And then we want to make sure this does not equal -1. All right, now disclaimer. All right, so this works because we are using only the tile blocks in our project. We are not doing any programmatically created tiles, okay? So that means that because this returns the same reference to a tile that you get in the actual tile map, it ends up like all working out, and we can do a strict equals check, and it will be compared by reference, so it will all work. Untied Arduino says, yummy, tall, conditional. Yes, it is very tall. By the way, this used to look really bad. Now it looks much better in the current arcade release, right? Like, Blockly fixed its rendering quite a bit, so.
Yeah, it used to be like, it would have less rounded corners in the top, so it wouldn't, it would extend past, other way around.
It used to totally break the bounds, which it doesn't anymore. Yeah. Nice. So anyway, because we are only using tiles here, we could do a find index of. If you are normally doing like an array of images, you do not want to use find index of, because it does not compare by value, it compares by reference. And because images are objects, that is not necessarily guaranteed to be equal, even if all of the pixels are the same.
Yeah.
But if you're using a tile image at block and you're using this block and you have not, again, programmatically added any tiles to your tile set, you're all golden. So don't worry about that. All right. So if it's one of these, then we want to go ahead and add this tile, this location to our array. So we're going to go into arrays. We're going to go ahead and do add value to end, grab our array of locations, add current location. All right. And then we want to recursively call this function in all 4 directions. All right. So we're going to go ahead and call trace path. We have our current location. And then we are going to, you know what, let's just make a loop for this. We're going to do a for of loop. We're going to grab an array. Wait, what am I doing? Array. And then we're just going to get all of the locations in direction. So bottom, well, I want to do this in the same order. Left, top, right, bottom. All right, we're going to loop over all of those, and we're going to go ahead and call trace path. The first argument is going to be current location. The second argument is going to be value, and we're going to pass an array of locations. All right. So right now, this function is going to loop forever because we are not checking to make sure that something is already visited. All right. So we're going to, for example, look at this tile, be like, oh yeah, that's one of the tiles we're looking for, add it to our list. Go to this tile, be like, yeah, this is one of the tiles we're looking for, adding to our list. Then we're going to check both of the surrounding tiles and go back to this one and say, oh yeah, that's one of the ones we need, and add it to the list, and so on and so forth. It's just going to keep bouncing between these 2 tiles. So we need to check if a tile has already been visited. Luckily, we have an array of locations, so we can check that out pretty easily. So we're going to go into up here at the top, and we're going to put in an if statement. And we need to, or actually, you know, we'll do a for loop. So we're going to do for element value of array of locations. And we're going to check each of these to see if they match our current location. Now, you might be like, why don't you use index of here? Well, it's the same thing I was just talking about. It's like, because this is by reference, and these are objects, locations are objects, we can't actually guarantee that these are the exact same object, so it won't work. It'll return -1 even if they do match. So we have to do a comparing by variable, which, by value, which we're doing right here. And inside here, if we have column equals column and row equals row, that means they're equal. So we are just going to short circuit and return. And this will prevent us from infinite looping. Well, we can still, no. Yeah, we're good. Yeah. All right. Okay, what's the next tile type we care about? The next tile type we care about is the switch itself. So if we find a switch, we're going to go ahead and add that to our list. The difference here is we are not going to recurse, unlike with these other ones. So we do want these because we're going to need to check them as part of our logic. But we don't want to recurse because we don't consider these connecting other things. And let me add a case for this to our. All right, so if I do this, flipping this switch should not flip this. That's basically what we're doing here. Okay, this is a little bit more complicated, actually.
Why?
Oh, okay. All right. Wait, we need to sit and think this through a little bit. Wait, let's go back to top.
The entrance matters.
Yeah. So let's imagine we have this scenario. All right. And we'll just go ahead and turn this one on. Okay. So this one is on. We want it to turn this on. And then when we turn this on, we want this to turn on.
But not the other two.
But not
the bottom and the
bottom one. Even though we are touching one that is turned on. So even if this is off, this should remain turned on.
Yes, they're their own gates. They're gates, not just connections, I guess.
Yeah. That is, unless we allow these guys to be treated as wires. Which, maybe that's fine. I don't know. I feel like it does limit us a little bit.
I feel like looking at it, what I expect is the behavior you just described of when you click the center, the top and right turn on and the bottom stays off.
Wait, sorry. You're saying that when I click this, when I click this, they should all turn on.
They should all turn on?
Yeah.
Even the bottom one?
Yes. We do an or, we don't do an and.
Oh. Yes.
But if this is turned off and these two are turned on, these should not be turned on, right? It should be this.
Okay. Yeah. Yes. Okay.
Okay. So this complicates things a lot. Because so far, actually, it's not that bad. Yeah, it's not that bad, actually. Yeah, okay, all right. So we're going to have to change our get all connected blocks function. So right now we are calling it for all four things. We no longer actually want to do this. We have to do all four separately, but that's okay because this function is going to handle that. So we are going to, inside here, we're going to go ahead and add our location to here, but we're not going to recurse, like I said. And then finally, are there any other tiles we have to think about? I don't think there are. So we just want to terminate. Let's see. So we have all the wall tiles. We have all of these tiles. Oh, right. We might as well grab the springs as well, right? In fact, we can just add that to this OR case because we are obviously the springboards are also not going to act as wires. I feel like that makes sense. Okay. So, all right, this is all good. Okay, so we now have a function that should give us a list in a current, in like a direction from our switch of all of the blocks that are associated with it. So that's good. Let's go ahead and we are now going to collapse this, and we're going to make a new flip switch function. So I'm going to just leave our current flip switch function as it is. And we're going to instead make a flip switch 2 that we can then use to replace this. So let's do flip switch 2. And this is going to take in a location. All right. So inside here, first thing we're going to do is actually flip the switch. So we're going to go ahead and see, you know what? I'm just going to go ahead and make this be set switch state. And we're going to make this take a Boolean, which is going to be on. All right, great. Okay. So what we're going to do now is we are going to do a for of loop. And we are going to do this for all 4 directions. So let's go ahead and do that right now. We're going to grab an empty array. And we are going to make a array of all of the directions. So that in there, just keep pressing plus until it goes vertical. There we go. And we're going to make the left, top, right, bottom. Okay. And now for each of these, we're going to go ahead and put in our switch. So we want to loop over all 4 directions of our switch. Okay. So now that we've looped over here, we are going to grab our temp location list, and we are going to set it to be equal to call trace path 2. We're going to pass in the switch. We're going to pass in wait, sorry, which of these is previous? Yeah, previous is the first argument. So we want to pass in switch. We want to pass in the bordering tile, and we're just going to pass in an empty array. Okay. Now we are going to, okay, so there's 2 kind of things we have to do here. Well, let's just lay it out entirely. Okay, so step 1, get all affected blocks. We just wrote that code. Step 2, check if legal flip. Okay, so remember, if the seagulls are overlapping with a wall such that if the flip was switched, it would trap that seagull in a wall, then we do not allow that flip to happen. All right. So we need to first loop over all of our locations, find any locations that are in the on state, or that in the dotted line state and would be flipped, And if they are, then we need to prevent this flip from happening. Okay. So let's go ahead and do a for of loop. Oh, yeah, right. And then step 3 is do the actual flip. All right, so we're going to go ahead and make another variable here so that we're not using value twice. We're going to call this, let's see, affected block. We'll just call it current location. Okay. Current location of our temp location list. And now for each of these, we're going to go ahead and see, well, first we're going to check, are we turning on or are we turning off? So if we're turning on, we are going to be checking the tiles that are the green dotted thing. So if it is the green dotted thing, then we are going to check, are any players overlapping with this tile? And luckily, we already made a function for that. So do players overlap with location? We're going to pass in our current location. All right, so if this is turned on, we do overlap with this location. This is invalid. We're going to go ahead and return false and not do anything. Now, in this other case, we're going to check for the blue tiles. So if it's blue and the players overlap, we're going to go ahead and return false. Okay. We have now checked to make sure this is a legal flip. So we're going to loop over all of our tiles a second time. And now for each of these, we're going to see, okay, if it's on and it's this tile, then we're going to go ahead and set it to be the on version of that tile. We should have just written the code like this from the beginning. This is so much cleaner than our old code was.
Yeah. Let's separate it out.
Okay. Oh, wait, whoops. That needs to be the on version. Okay. So, else if this is the blue tile that's already on. Now, for this case, we need to loop over all of our locations and see, is there a switch that is on? And if said switch is on, then we want to not flip this. So we're going to call this other location. Oh, whoops. Go in here. Make this other location. And we're going to see if tile at other location is, and see if it is a off switch. So if it's an off switch, then we do not want to flip this tile. So let's make a variable. We'll call this found invalid or found active switch. We're going to set this to be false right here. Inside here, we're going to set this to be true. And then we're going to do an if here, and we're going to do if we did not find an active switch, then we are going to set the dotted line at our current location. All right. I think that's that.
Awesome. Okay.
The only other thing we might want to do, which you know what I'll do right now, is we should also just check to make sure that this other location, sorry, this should be other location. Okay, it's a good thing I read over this code again. There we go. We should make sure that this other location is not equal to our switch location.
Is not what? Equal, you said?
Yeah. Because if we are, we don't care about the state of our current switch because that's what we're switching. So we need to make sure that this is not equal. Okay, we're going to make this be column. We're going to make this be current location. And then we're going to make this other one be switch. Pull this down here. I forget, Joey, did you try to pre-order the Switch too?
I put in the Nintendo thing, and they said they're gonna email me about it soon, but I haven't decided if I'm actually gonna get it.
Okay. Yeah.
So I put in the light pre-order.
I'm in the same state. I'm in the pre-order state. I mean, I will pre-order it if they send it to me because, you know, I buy video game consoles. That's what I do. But
yeah. I probably will get if assuming they send me the email, but it's just kind of like a.
All right, we're gonna put a break in here also because there's no reason to keep iterating once we've found it. Okay, so if the tile at location is off and it is not our switch location, then do this.
Yeah.
Sorry, what were you saying?
I could wait for a fun version of the console. If you know, that'd probably be a year before they make like an.
You won't be able to play Mario Kart for all that time.
Mario what? Mario Kart? Yeah.
Yeah.
I wouldn't be able to beat a Moo. That's true. Kind of messed up, honestly. It's really messed up, honestly.
Well, what's really messed up, as I've said before, is that Ludwig von Koopa is not included. So, okay. All right. So if we're not flipping on, we just basically want to switch all these green ones with blue ones, which luckily the copy and paste is currently broken on our thing. So it already blanked out all the tiles for us. All right. So we are going to make this be, it is not on. So we want to see, is it a dotted line? If it's a dotted line, then we want to flip it. If it is a solid green, then we want to check to make sure that there is not a bordering active switch. And if that is the case, then we are going to turn it into the dotted line.
One thing I'm thinking of while we're doing this one, it's a bad idea, but maybe a funny one.
What?
One more color of like dotted to do one that just toggles every time a connected switch is toggled.
That's interesting.
So you know the
one, no, I like it.
On the current state, and then that one is you know you have to line up the sequence.
Mm-hmm. That's good. I feel like we will definitely have to explain that is what's happening.
Yes, I mean that one will need a very clear tutorial level, right?
Yes. Unlike the other ones where you can be like, okay, color matches, that makes sense.
Yes. This one is just like rude.
Yeah. Okay, I think we have finished our function. Oh no. Last thing, very important. We need to actually set our switch at the end and fix all the walls. Right. So grab the on down here, bring it down here. And we are going to set our tile at our switch location to be the active tile. Else, we're going to set it to be the inactive tile. There we go. Right? Okay. All right. This is almost correct. Right. Okay. There's one problem with this, which is that right now we are doing this return check once for each direction as we go around. But we need to actually do all of the checks up front, I realize now. So we're going to duplicate this whole thing. We're going to just pull out this bottom part, and then we're going to pull out this part. And now we should be good. Okay. So we're looping over all of our paths. If any of them are invalid, oh, whoops. If on, if that, if off, if that. So if any of these are invalid, we are short-circuiting the entire switch and returning. And then we do the actual switch down here, and then we do that. So that should be good. Okay. And then the last thing we need to do here is like create that little red switch. So we're actually going to do that inside of our flip switch function. Okay, I'm going to save now because we have now gotten into the destructive part of this refactor. I'm going to go into flip switch, and I'm now going to pull out this whole thing and throw it away. And we're going to go ahead and call this new function we just made. Set switch state. Going to put in location. And we are going to put in here, we're going to see is location on or not. So do scene, grab tile at location is, put in location, and then we are going to put in that. Okay, so this will set it to on if it's currently off, or off if it's currently on. That's great. Oh, right, and I forgot to set the walls. So let's go ahead and set the walls real quick. We're going to go into tile util, and then we're going to do set wall. And we're just going to update the walls for all of our tiles. So, oh, whoops. Go back. Oh, okay, wait, this is the wrong one. I want the, let's see, set wall on at all locations, right? And I want to do that for all of my things. So we're going to set this to be all of the on versions of our walls. And then we're going to set it off for all of the off versions of our walls. Great. All right. Okay. Close that. All right. Now in here, if this returns false, that means the switch did not happen. So we're going to go ahead and go into here and put in a not. And we are now going to create our little blinking switch thing. So let's go ahead and do set my sprite. We're going to go into here and then, oh, I need to redraw it because I threw that away callously. 8 by 8. Let's see, it's white and purple. So white, purple. Come on now. And then we're going to make this red, and we're going to make the little highlight orange. So we're going to make this a kind decoration. We're going to make this be temp sprite. We will place it on top of location. And we will give it a lifespan of, I don't know what we did before, like 800 milliseconds or something. And for good measure, I'm going to set ghost on also. I don't think it actually matters, but it's, you know, we do want it to be ghost, so might as well. Okay. All right, so this should now be working. All right, not quite. It's getting there though.
Yeah, I mean it does the
This is all working, right?
yeah. It does all but the one weird case that we talked about right at the beginning. Is that correct?
Wait.
Oh. This is an interesting game. It's not the one we made, but it's an interesting one.
Okay, all right. Wait. Oh, wait, no, it is working right because this one's off.
I'm not sure it's
Yeah, this is
totally
working
working
correctly.
right because of the last situation, but that does make sense now. Okay, now that you mention it. Oh.
Right? Is there anything wrong with this? This is correct.
Yes.
All right, we did it.
What was
so
the
last thing
the clicky thing where you were making a bunch of switches up?
Oh yeah, we'll fix that.
We just didn't have a check on the click event.
Yeah, we're setting switch state and we're not actually checking to make sure it is a switch. So we're going to go ahead and do that check right now. So we'll do tile at location is this. So we want to make sure it's one of these. If it is one of those, then we're going to do this. Otherwise, we're going to do nothing. Okay, so that should now take care of that. Cool. Okay. So let's load up our level that we were doing. So we're going to pull out this test level and put, wait, this one. No, wait. Oh, this one. Yeah, it's right here. So there we go. This is now working correctly. So I can flip this and then flip this. And they fall down here. And then I want to flip this, and then we did it. Hooray. All right, cool. Onside Rita says, might as well make redstone at this point, LMAO. Yeah, we're kind of doing redstone.
I mean, yeah, we'll get there.
Yeah. I mean, obviously we don't have everything that you can do in redstone. All right, we have one last thing to test. So let's actually bring back our test level. I'm going to duplicate this and then throw this out, stick this in here. We need to make sure we didn't break the invalid flipping behavior, right? So we're going to go ahead and put in some switches right here and make sure that we're not going to break that. So go flip. Okay, 800 is too long for this blink. But it does seem like we're okay. Yeah. Make this be more like oh yeah, here it is. Make this be more like 200. Yeah, there we go. Cool. Okay, cool. Well, we refactored all of that. So now we can make some more levels. Really fun. And let's go ahead and capture Joey's brilliant idea while we're doing that. Make a block that always toggles.
I thought we were going to get through the day without a spam bot.
Without what?
Spam bot.
Oh. All right. And the last thing that we also have to add to our to-do list is we fixed this for the player switches. We need to make this function also work for the non-player switches. So since we've already, this is gonna be very easy for us to do. And hey, it might actually fix a bug that we had, I guess. No, we didn't have a bug. Nah. But anyway, so we're going to refactor our other switch code to use this same function, and then we can delete all of those myriad of other functions that we had that we were using to do these checks before.
It's nice to have it all in one.
Yeah. All right. Thanks for watching, everybody. I am Richard at Richard on the MakeCode Forum.
I'm Joey at J1Draw on the MakeCode Forum.
And we will see you all on Wednesday. Reminder, mini game jam is going on right now. It's construction themed, so you can find all the details about that on the forum. Make a game. We'll play them all at the end of next week on Friday. So see you then. Bye.
Bye.